Dear students, today we will learn about the sample and hold circuit. Its name suggests that sample and hold circuit is a circuit which samples an input signal and holds on to its last sampled value until the input is sampled again. It is also known as track and hold circuit. It is used to sample an analog signal and to store its value for some length of time. It is prominently used in data converters. Sample. It is also said track. It acquires the input signal and tracks it faithfully until commanded to hold. It is also known as sample hold or track hold. Here in this block diagram you can find that this is the input, this is the output. There is a control input. If control input is 1, it means this input is for the sample command. And if it is 0, this is for the hold command. Here you can find that this is the sample, this stands for the hold. This stands for the hold. This is the input. Basically this is the input where it is being sampled, and after that this is hold. You can also see from this diagram also, this is the sample, after that this is a hold. It is only possible by using the control signal. To understand it in a better way, we should know that its parameters. Acquisition time, it is a time required for instant switch close. Aperture time, it is a time required to open the switch. Then there is a decay rate of discharge of capacitor when circuit is in hold mode. Capacitor, it means when it holds, capacitor is used. We will see in the upcoming section. Droop rate characterizes a slow change in input voltage in hold mode. Sampling pedestal, it occurs each time. It goes from sample mode to hold mode. Another parameters are dynamic range, linearity, gain, offset error. This you have already studied in your digital electronics also, in the analog to digital and digital to analog converters. Another parameter is the speed, aperture jitter or uncertainty. As we said that sample. So how does the sampling is done? It is based on the sampling theorem or Nyquist criteria, means frequency should be twice as high as the highest frequency expected in the input signal. So your fh should be greater than or equal to, then it can be sampled. Fh should be greater than and equal to 2fh, then it should be sampled. Fs is the minimum sampling frequency. If it is equal, then these will coincide with each other. In this case, this is greater, so that's why you will find that this is the region. In case if it is less than 2fh, then this will overlap. If it will overlap, then there is a chances of aliasing. So we should have to avoid the aliasing by using the sampling theorem or Nyquist criteria. Practical sample and hold circuit. Here you will find that an operational amplifier. One is in a control input is applied through some switch. Input is applied, capacitor is used to store, and this operational amplifier is simply acting as a voltage follower. V0 is the output. Control input open and closes solid state switch at sampling rate Fs. The voltage V0 would ideally stay constant in the hold mode by having a value equal to V input. When it is going to hold? When V0 is equals to V input at the instant of clock going low due to switch. This we also see in the upcoming sections. This is the circuit diagram. It is an operational amplifier. Switch is being replaced by MOSFET. MOSFET switch, input is applied. There is a signal has been applied to the MOSFET. Capacitor is there. Operational amplifier. This resistance is used to offset the null voltage. This is the resistance at the output. This is the output. So that's why it is said to be sample and hold circuit using operational amplifier as well as MOSFET. This is the MOSFET. So we will see how it works. Its operation. MOSFET will act as a switch while operational amplifier will act as a voltage follower. Input voltage V input is applied to the drain of the MOSFET. Input voltage is applied to the drain of the MOSFET. And control voltage is applied to the source of the MOSFET. You will find that this is the control voltage. It is applied to the source of the MOSFET. MOSFET source pin is connected to non-inverting terminal of the operational amplifier via resistance R3. Here you will find that it is connected to the operational amplifier through resistance R3. C1 acts as a charge storing capacitor. This is the capacitor. Its value is normally 0.1 microfarad. It is of the polyester and it is used to store the charge. R2 will be the load resistance and R1 is used for adjusting the offset voltage. This is the load resistance. As I have already explained it to you, this is used to minimize the offset voltage. Its operation during the positive half cycle, when Vs is equals to Vp, MOSFET will get on and acts like a closed switch. You can say in this diagram, when this is on, MOSFET is on, it is going. It is increasing as the input is increasing, output. Till here, till the MOSFET is on. And acts as a closed switch. At the same time, the capacitor C1 will get charged by V input. You will find that this capacitor will also charge through this input voltage. And the same voltage will appear at the output of the operational amplifier. This voltage will appear at the output of the operational amplifier. When Vs is 0, MOSFET will get off. See how. When this is 0, so it means MOSFET is get off. So this is the hold mode. See. Get off and the capacitor will get discharged through the inverting terminal of the operational amplifier. So when it will get off, this capacitor will get discharged. As input impedance of the operational amplifier is very high, the voltage V input will get retained. As we know that in case of the ideal operational amplifier, input resistance is almost infinite. So in practical case, it is very high. So this voltage will remain at the output. This V input will be appear at the output of the operational amplifier. So this output will appear at the operational amplifier. Further, when MOSFET is again on, it will follow the input exactly. When it will get off, it will hold for this way. Further, this procedure will continue, and this way sample and hold circuit operates or functions. Sample and hold period. The time period of the Vs during which the voltage across the capacitor Vc is equal to V input is said to be sample period and denoted as Ts. In the same way, time period of Vs during which the voltage across the capacitor Vc is held constant is said to be hold period. It is denoted by Th. These are the applications of sample and hold circuit: analog signal processing, communication circuits, data distribution system, data conversion systems, digital voltmeters, pulse width modulation circuits, sampling oscilloscopes. Thank you. Dear students, I hope that you have understood the concept of the sample and hold circuit. In case of any query, feel free to call or message me. Thank you.